right, good morning, Honors Integrated 2. This is the second time I've made this video. Oh my gosh, so frustrating. User error. I have nobody to blame but myself. I sure wish I could blame somebody else, but it is what it is. All right, so what are we talking about? We're talking about arc length and radians. Today I'm going to put radians on the shelf for now. We're going to talk about arc length, but first I want to discuss the difference between arc length and the measure of an arc. Now take a look at my fairly decent circle actually. And look at this, isn't that a right angle and isn't that a central angle? So if this is 90 degrees, if the central angle is 90 degrees, that means that this arc is also 90 degrees, 90 out of the 360. So the measure of arc AB is going to be 90 degrees, and that's what we did last week. That's not what we're doing today. Today we're doing arc length. This is the measure of the arc. That's fine, 90 out of the 360, but I want arc length, like literally how many inches or centimeters or meters or whatever is this? How long is it if we stretched it out and just measured it? Well, it turns out it's actually really quite simple to figure that out. And to figure it out, I'm going to remind you of the circumference formula. The circumference is 2 times pi times r. Now, what the circumference is, of course, is the length all the way around the circle, right? It is basically the perimeter of the circle. So it's the length around the circle. Well, let's pretend for a second that the length around the circle is 20 inches. That is, the circumference is 20 inches. So that's all the way around is 20 inches. Well, wait a minute. What would be the length of arc AB? All right, well, now I'm just going to put AB, arc AB. It doesn't have the M, that's the measure. This is the arc length. Well, think about that for 1 second. Isn't it true that arc AB is 90 degrees, which is 90 out of the 360 degrees in a circle? And 90 out of 360, that's 1/4. So really, don't I really just need 1/4 of the circumference? Well, yeah. So what is the arc length? Isn't it just 1/4 times 20, and isn't 1/4 of 25? So the arc length of arc AB is 5 inches. How did I get that? Well, it's just a quarter of the circle. If the whole circle is 20, 1/4 of it is 5. So the keys to this whole thing lie in this fraction right here. We're basically saying, what fraction of the circumference is it? So that's arc length. Let me show you the formula for that. All right, here we go. Arc length formula. For some reason they use S. I don't know what that reason is, but it's a pretty simple formula. You should write it down. The measure of the arc divided by 360 times 2 pi r. But let's break this down. Isn't this the circumference? That's the circumference of the circle. And isn't this the fraction of the circle we're looking for? Look, it really is that easy. Not very complicated at all. This is the formula. Plug it into the formula and you'll get it. Let me show you an example. All right, so here's an example. Find the length of arc BC. Here's arc BC. Now, we don't need the measure. I've got the central angle. It's 110, so is that. That's 110 degrees. What I need is the arc length formula. S equals the measure of the arc, which I know is 110 divided by 360 times 2 times pi times r. All I have to do is plug some numbers in there. That's 110 divided by 360 times 2 times pi times 4, like so. So that's not very hard. You could just put all that in your calculator and just get a decimal, round to the nearest tenth, and you're done. I want to show you something else though real quick. What if I did it slightly differently? What if I just reduced this real quick? What is that reduced by? Well, it reduces by 10 for sure. So that's going to be S equals 11 over 360 times 2 times 4 is 8, and I have 8 pi. If I remind you that that's over 1, I can get S equals 88 pi over 360, and then I can reduce that. And if I reduce that by what, 4, 8? Oh, 8 should go. Does 8 go into that? Let me think about that real quick. All right, so 8 did go into 360. Did that on my calculator real quick, and I got 11 pi over 45. Now look, this answer is something called in terms of pi. sometimes a book or something will say, leave your answer in terms of pi. That's what it is, 11 pi over 45. That said, if all you did is just plug it into your calculator right at the beginning to get a decimal, and that is acceptable, by the way, you would have gotten approximately 0.8 inches. Let me double check that real quick. Okay, so today's my day to make mistakes. Apparently, I made a mistake, and I knew as soon as I did it, and I got that answer. It was kind of strange. When I divided everything by 10, I left that bottom 360. It should have been 36. Duh. Oh my gosh. So this is an 88 pi over 36. It's 88 or 360, it's 88 pi over 36, which that's definitely going to change it. I can reduce that by 4, though. I know I can reduce it by 4. And if I reduce it by 4, I get this. I get 22 pi over 9. I apologize. I appreciate you sticking with me real quick. And again, if I just put that into my calculator just to get the decimal, then I should get this. So I should get about S equals 7.8. Again, I guess I'm just making mistakes this morning. I didn't even trust my answer, even though I got it right. So 2 things. You could just put this whole thing right here. Let me just put a big rectangle around it. You could put all that in your calculator right now and just get this decimal answer. That's fine. But this right here sometimes is required. Answer in terms of pi. All right? Pretty simple. Use the formula. You got this. All right, here's kind of a different type of example that your book kind of gets into. The minute hand of a clock is 7 inches long. So that would be right here in my drawing. This blue arm is 7 right there. How far does the tip of the hand, that's right there, travel from 10:15 to 10:35? Well, if you don't know how to read a clock, that's a problem. But I have 10:15 right here. 10:35 would be right there. So how far did the tip of this hand travel from the 3 to the 7? Well, let's look at it. How many minutes is 10:15 to 10:35? I think you can see that that is 20 minutes. 20 minutes out of how many? Well, isn't that 20 out of 360, out of 60. 60 minutes is what it takes to go all the way around. So what would that arc length be? Well, it'd be 20 out of 60 times 2 times pi times the radius, which is 7. And that, of course, is the length of the hand. So there we go. All I had to do was kind of adjust the formula a little bit and use this 20 out of 60. That gives me 1/3 of the circle. The minute hand traveled 1/3 of a circle. So it's basically 1/3 times that times that. Put that in your calculator, get your answer. Let me do that as well right now, just real quick. And again, you can use 3.14 if you'd like to. That's completely fine. And here's what I get. I get the arc length, and hopefully I didn't make a mistake, 14.7 inches. That's how far it went. Pretty simple. Take a look at it. Okay, something else, something called concentric circles. What are concentric circles? They are circles that share a common center, like these two. I have a small one, and I'm going to name that radius S for small. And then I've got a big one, and I'm going to name that one B for big. Here's something important. The radius and arc length are proportional. What does that mean? It basically means this. The big radius compared to the big arc length is equal to the small radius and the small arc length. Remember that proportions are really easy. It doesn't really matter how you set it up as long as you're consistent. This is one way. I take the radius of the big one and I compare it to the arc length of the big one, and I compare that to this. Pretty easy cross product property. You got it. One more thing I need to talk about is something called radians. Let me show you what that is. Let's talk radians. Radians are simply a different way to express degrees. I want to remind you, back when we used our scientific calculator, if you wanted to use sine, cosine, tangent, that you had to have your window set to degrees. Well, you can also set it to radians, and that's because they are equivalent. For example, if I have 360 degrees, then that's equal to 2 pi radians. See, these are equivalent. It's just a different way of expressing it. If I took that and I divided by 2, I'd have 180 degrees, and that's going to give me pi radians, like so. And the last one that I'll show you, what if I just divided that by 4? 90 degrees, that's going to give me pi over 2 radians. So these are just equivalences. And honestly, we got to transfer, we have to change from one to the other, and it's pretty simple if you remember this simple fact. Pi equals 180. Let me show you what I mean. All right, today you will have to change degrees to radians. It's a pretty simple process. Just multiply by pi over 180 and reduce, like this one. Watch, what if I do this? Example, change 45 degrees into radians. Well, what did I tell you to do? Multiply by pi over 180. All right, well, pi over 180, like that. And if I'm smart, which I try to be smart, I'm going to try to cross cancel here. I'm going to divide by 9. That gives me 5. That gives me 20. Then I multiply straight across, and that is 5 pi over 20. And that's pretty good, but the 5 and the 20 can be reduced a little bit further to 1/4. So this is pi over 4. There we go. 45 degrees is pi over 4 radians. That's a pretty simple thing to do. All you got to do is multiply by pi over 180 and reduce. But what about the other way? All right, what if I'm changing from radians to degrees? Radians to degrees. All right, well, radians to degrees, what did I say? Substitute 180 for pi, then reduce, like this. What if I give you 3 pi over 5? All right, that's a radian, and I need to change it into degrees. Well, what did I say? Substitute 180 for pi. So, okay, let's go like this. 3 times, this is 180, and divide by pi. Well, 3 times 180, that's 540. I got that. 540 divided by 5 like this. Well, if I just divide that, that's 108 degrees. Boom, done. That is simple. You got to do all that stuff on your homework today. Speaking of your homework, what is your homework? Here it is right there. Take a look at it. Read it in the week, people. That's where we're at. 20.2, 1 through 19, 23 to 24. That is due on Thursday. We'll see you guys later. Take care. Hit me up with questions.